Good evening, everybody. I'm Nick Rishwain. Welcome to episode 5 of Robotics Live, where we discuss all aspects of robotics, artificial intelligence, cognitive computing, and we help break it down for the layperson like myself who's got a background in the law and not in BCI, brain-computer interfaces, or any of these very sophisticated sounding words. With me tonight is Marvin Andujar. Marvin is a PhD student in human-centered computing and a National Science Foundation graduate research fellow at the University of Florida. He is under the supervision of the Andrew Banks Family Preeminence Endowed Chair, Dr. Juan E. Gilbert. Marvin's research concentration is on brain-computer interfaces, or BCI, where he focuses on measuring and enhancing the user's physiological engagement levels with wearable electroencephalographic technologies. Those are EEG technologies. Marvin holds a BS in computer science and a BA in mathematical sciences from Kean University. Marvin, welcome. I'm glad you're here tonight.
Thank you for the invitation.
My pleasure. My pleasure. I see that you're working on some really fun stuff from my perspective, very fun and interesting things, and I'm sure from your perspective too. So I'm glad you can be here to share with us what you're working on. Can you tell us, for the layperson, a little bit more, what is brain and computer? What is a brain-computer interface?
Yes, so that's an area that has been pretty much going. The medical field has been working on this field for ages. So since the 80s, even before it was introduced, people have been using electrical signals like EEG to get signals from the brain. But there are two main purposes when it comes to brain-computer interfaces, which is one, to understand how the brain behaves, and the other one is to control machines with your brain when it comes to like neuroprosthesis, wheelchairs. And for our work, it will be drones or any other type of robots like a humanoid, like the now humanoid. So those are the two main purposes. When it comes to understanding the brain, it's pretty much how understand the affective state and recognizing the affective state or emotional state, how the person, or pretty much the user, feels when they interact, perform the daily activities, or they interact with different technologies. In this case, like, if you are talking to a humanoid, how would that person feel?
Okay.
Yeah.
And I want to slow you there for just a second, because one of your areas of specialization is effective brain-computer interfaces. So when you say effective, that is the human's feeling towards the machine?
Yeah, human feeling towards pretty much anything.
Okay.
Yeah. In this case, my PhD is on human-centered computing, which is developing applications for the everyday user. Okay. In this case, will be the machine, pretty much any type of computer.
Okay. So it's any type of computer, and then from there, your research has kind of merged into this use of the drone as the type of computer that or machine that you guys are using right now. Yes.
So my personal pretty much interest when it comes to affective BCI is to quantify the brain. You're probably familiar with quantified self, where people like to pretty much Fitbit. It's a very good example. That's a quantified self device where people like to count the amount of steps they actually do per day, and how does that translate to how much pretty much calories are you burning per day, and then calorie consumption, and how does that compare to how much calorie are you burning. So when it comes to quantifying the brain, what I mean is, like, can we get the affective state of a person, visualize it on your phone or on a smartwatch, and that person can be able to self-reflect from their actions. So a good example can be, let's say, towards education. Let's say you're wearing a brain-computer interface device. It can be one of the wearable BCIs. Like, for example, you can choose like this one, which is one of the ones that we use for the brain drain race. It's an emotive device, has 5 channels. Can talk more about the device later. Pretty much, if somebody's wearing this kind of device and they're learning a piece of information, can we measure, let's say, level of attention? Sometimes we're just reading something and then, attention just we think we're reading, but we're really not reading. Can we actually quantify that, all getting the information from the brain? As soon you're done doing that task, can we show you like a metric saying, okay, you were 50% pretty much paying attention to this reading. Now that person self-reflect, pretty much, okay, thinking, I need to pay more attention in my second time, I'm going to read this. And hopefully once you do that, you'll be able to see an improvement in your attention level. So pretty much it's combining quantified self and brain computer interfaces and pretty much making it accessible to everybody.
This is exceptionally interesting to me because I suffer from ADD and dyslexia. So I have almost since college had to read everything twice before I started to comment on it. So it sounds like this might give me some indication as to, hey, pay attention because you're not engaged in what you're reading right now.
Yes, so that's pretty much the purpose, to pretty much help everyone, even those who have to read the same text over and over again and pretty much wasting time.
Right.
Especially, let's say if you have a quiz tomorrow, you cannot be wasting time, especially if it is 1 a.m.
Right.
So, but if we're able to actually, from the research aspect, does this actually help people pay more attention? And to a point where the first time you're about to read that information, you are already paying attention to a specific level. So that's pretty much to see how can we improve your learning behavior.
And I imagine the retention will then improve as well.
Yeah, so that at least to us, we're trying to find to see if there's some retention there. And,
excellent.
Like, okay, you improve your attention level, but are you actually performing better at the quizzes that you take in your course, or be able to recall more information as well, now that we are making you aware that you're paying more attention? That's my interest in the affective BCI side, and pretty much what we call quantified self. And especially the quantified self movement, it's pretty big nowadays. So that's like one of the hot areas, and that's why I probably should combine both. I mean, two hot topics.
Yeah, I like that.
Yeah, I think it's really needed in this area. But then the other areas of brain-robot interaction, right? So what I mean by brain-robot interaction is the ability of a person to communicate with a robot with the brain. Well, I mean, communication is pretty much control. Pretty much control the actions of a robot. If I wanted to move forward or flip or land, anything I wanted to do. But also, there's something we call in brain-computer interfaces is hybrid BCI, when we combine like two different type of brain sensing technology, like EEG or FNIRS, where like FNIRS read the amount of oxygen in your prefrontal cortex, and EEGs pretty much read the electrical signals of the brain.
Okay.
Or even when you combine it with EEG and heart rate and other type of physiological measurements. But we still call it hybrid because we try to understand how the person, pretty much the affective state, how the person feels when they control robots with the brain, right? It's like, I can probably give a survey out to the population and ask, how many of you go home and try to control a robot with your brain? They'll be like, what? That's not even possible.
Right.
Yeah, the metric is not real. But what we're interested on, something that we have been observing, when people actually, at least for the brain-drawn race, they had to do a qualifiers round. And like 100 people had to come to the qualifiers, and those who didn't perform that well, we asked them like, do you know why do you perform this well? And they're like, well, it's very hard for me to concentrate in just one thing. So we already okay, then we started thinking, okay, so probably this can be some sort of exercise that pretty much help people just concentrate on just one specific thing. Because to control a machine, they had to go through a training first. Pretty much when it comes to BCI, we had to teach the brain-computer interface device the brainwave patterns, right? So we create a profile for that specific person and save how pretty much do you think when what is the patterns of your brainwaves when you pretty much think of a specific action. So of course they had to do a baseline, which is the neutral, where they blank their minds, close their eyes, and pretty much we get alpha waves. Okay. Pretty much means relaxation. And then when it comes to the actual action, which is moving a drone forward or anything forward, and pretty much we actually save that information. Okay. Now, we have noticed that people perform at very different levels. It doesn't matter. It doesn't matter what kind of machine are you controlling. If it is like a visual character in a video game or a drone, anything at all, people perform at different levels, and that is because, at least from what we have observed, is that some people are just very good at concentrating in just one thing, and some others cannot concentrate on just one thing. So when some of the instructions we give to the those who work in the qualifiers, like, okay, imagine you're pushing a cube or a box forward your hands, or you're walking forward, something simple. And some people were able to do really good, and some others kind of came up with a very complicated thought, like running with a soccer ball. I'm like, okay, there are too many variables in that thought. So I saw that they were not performing that well, at least in the training phase. And then I tried to come up with something simple, like pushing a cube or a box forward, or even a table or chair. And they were able to actually improve, perform way better once they were able to simplify their thought process.
Have you noticed, or maybe there's no data on this yet, but are you able to tell whether or not somebody based on intellect is more capable or less capable to do these things, or age or any of that? Is there any data on that yet, or whether they're more able to control a robotic or a drone, or less able to?
I have not seen necessarily some type of data where pretty much for the everyday user, where they'll be able to compare somebody who's like 40 years old and somebody who's 10 and somebody who has more education than somebody else. To be honest, that's actually one of the questions that I was at the Brain Computer Interface meeting in California in May, where all these BCI researchers come from everywhere and meet. And we were discussing, like, yeah, some people just perform so well and some people just don't. Like, and then that's the thing, like, how can we actually come up with some kind of grouping that actually say, okay, these type of people perform better, they don't perform better. How can we actually help them so they can perform better? And that's actually still open. It's an open question.
Okay.
So that's some of the things that we hope to figure out one day. How can we actually know who's going to perform better than the other just based on their experience?
Interesting.
Yeah, and well, some of the data we also have been collecting is before they even do this kind of pretty much controlling a drone, we ask them how do they feel before they're about to do this activity, and we have a certain type of questionnaires we get from affective computing, and we pretty much get their emotional state before then, before fact, because anything can happen to you before you come to the actual qualifiers. Like, I don't know, life happens, and then you come here like, oh yeah, I came here to control a drone with my brain, but I just failed my class or a test, and then see other person, oh my god, I got a raise at my work, at my job. Oh yeah, I came here to control this drone. So that's one of the things we would like to see if there's a kind of a correlation in performance.
If there's positive emotions or negative emotions happening in their life, and how that may affect their ability to control.
Yes.
Okay.
Yeah. So because it's all about how much attention you're putting into the control. At least that's how we actually prepare it. And then if you're really distracted with what is going on with your life at that time, we hypothesize that you shouldn't be able to perform as good as somebody who's just happy and pretty much had nothing else to think about.
And have you noticed, has there been any data yet that you've noticed related to stress? Certain times stressors help people to achieve greater focus and things like that. So like certain focus that would go with a fighter pilot or something like that under great stress, yet performing exceptionally well. Have you noticed anything like that at the levels that you guys have researched so far?
Not necessarily. That's actually a good question. But there's certain things that we had to think of first, right? So like I mentioned, not too many people are used to controlling things with their brain. So when they see it for the first time, the first thing, kind of feeling they get is excitement. They're like, wait, I can do this with my brain? Like, so it's very, so the first you get excitement. And then at the actual race, you still feel excited, but you still feel like kind of, okay, I'm in the presence of many people, the media, and I need to take this drone off so I'm able to win. And so it's still data we're still collecting. But yeah, that's a very interesting question. I mean, again, it's excitement that comes to people first. So I would say we'll be able to get better data once people are used to having like a brain computer interface at home that is actually cheap enough that people will be able to buy it. People actually know this kind of technology exists, which is one of the main reasons why we did the brain drain race, to let everyone know in the country and everywhere else that this is actually possible. And even then, we get people saying like, "Oh no, I had to try it myself for me to be able to be convinced that this technology actually exists."
It's interesting that you say that. I have a good friend through the social media channels who's active in virtual reality. And a part of the she's participates with VR Scout. Whether or not you're familiar with them, I'm not sure, but they have an actual studio where people can come in and use the real VR, not just like the Google Cardboard VR or something like that. And that type of experience changes the way people perceive.
Yes.
So what I'm seeing in the videos that you've shared, the one that's on your website and the one that I have at the bottom of the chat here with the brain drone race, you know, it's one of those things where, well, if I were to fly out to Florida and come and visit you, and maybe then I might have the chance. So that makes it difficult as a consumer to really think that this is available to me. So, because it's the same thing with going to visit my friend in LA. That's where I know that there's a studio that I can play with virtual reality, right? So which would lead me to my next question. What is the chance that, like you had in your hands there, you had a BCI in your hands. When will something like that be available to the public?
It's actually available right now.
It is.
Yeah, anybody can go to emotive.com and buy this device right here. Yeah, so they had different, I would say, premiums. They had the basic version, the premium version. Premium, of course, is more for researchers. The basic version is for just regular consumers, and you can download the application in your phone and pretty much do meditation, things like that. For us researchers, of course, we're trying to go even more than just meditation. But you can just buy the device, and there's also more devices like the MUSE from Interaction Company. That's a Canadian company. It's like a headband on your forehead. There's also the NeuroSky, which is even cheaper. It's actually an older company than Muse. There's also the movement of OpenBCI. That's actually a fairly new company where they're trying to pretty much researchers and developers, designers, and just regular consumers be able to use their own BCI, build their own BCI, and be able to build any kind of application and do the things that we actually do here in the lab and at a cheaper cost, because that's one of the biggest challenge. How can we bring devices that cost like $50,000, and how can we make them accurate enough that we can get good data, very accurate data, and cost at the same time $400, $500 or less that anybody can actually use. So once they actually get cheaper and people pretty much know that this stuff exists, even more people, then they will buy their own BCI, and people are already buying their own drones, right? For drone racing, they have the drone racing league. And once they're able to buy both, and hopefully one day there's just one package that people get their BCI and the drone and be able to practice at home, then they can go to brain drone races, let's say regional or even countrywide, and compete. That's one of the reasons why we hosted the brain drone race. So
that's fantastic. And now I want to get to the device you had in your hand. Can you tell us what is that one called again?
Emotive is this Emotive Insight?
Emotive Insight.
Yeah. So this is the Insight. They have another version as well. It's called the Epoch.
Emotive, no E at the end, right?
Yeah, no E.
Okay, so I spelled that wrong. What centers of the brain or what areas of the brain is that particular device reading when somebody buys it? Can you give us an indication of what it senses and what it reads?
Yes. So like all the devices I mentioned, they're all EEG devices. So they read electrical signal from your brain. And all the devices follow a standard system called the 1020. So every single EEG device had to follow that international system. So here, these two channels, they're going in your forehead, pretty much in the frontal lobe. So you're getting from the frontal lobe. This one here is more in the temporal lobe, and also that you have some channels here, and here also more in the parietal lobe. So you're not really getting any ones in the back, which is occipital. But if you buy, let's say the Epoch has 14 channels. So the more channels a BCI device has, the more regions of the brain will actually cover. And more information, you can get more information from it. When it comes to the brain-drawn rays, we think this device is really good, especially when we're using mainly two channels, because it's mainly for control. And especially when you're just doing one command at the same only one command. Then when it comes to effective BCI, I like to use devices with more channels for more accurate data, and also to get more information from the region of the brain and things like that. Because I'm assessing the affective state, the emotional state of a person. I would like to get as much data as I can, good accurate data as I can.
I noticed that in the Fox video that you did, where the anchor or the anchor was trying it out himself. That one looked like it had a lot of sensors in this area. Is that what areas is that? So that's searching for the emotion. That's going for more of the emotional state of the person or the affective BCI.
No, so they actually have 14 channels. That one. So it's actually ranged from the frontal to actually in the middle and in the back as well. So it is called the Emotive Epoch. That's actually the first device they actually released. And that's the one we actually started working with for when it comes to the drone. But then we moved to the inside for the brain-drawn rays, as you know, it was a large event, and we needed to change the devices across people very quickly. And the Epoch does take some time to mount the device on people. Like you have to weigh the electrodes, and then you have to actually move the device around to get really good accurate signal. So you're not getting garbage signal. However, you still be able to see in the Fox new video, the anchor was able to do it right away. We did the training right there. He was like, "Oh, can I try it?" And that was the first time we had anybody from outside trying it. I was like, "Sure, yeah, you can try it." And hopefully this stuff works, and it worked.
Yeah, it did. It worked
in like 5 minutes, and he was surprised too. I was able to do it within minutes. I thought it would actually take longer time, and that's when it came to us like, if we can able to do it from in Anchor and get good signal right away, we can go and do a brain-drawn race.
Yeah,
and that's how we move towards it.
And maybe you can describe for us, because it was only, and this will be difficult since we can't really put up a screen to show people, but as I saw it in the video, the Fox video, it looks like the anchor or even the model that you were using, Philip, I think his name was Philip, they don't look at the drone. They're not controlling they're actually looking at a computer screen and trying to control something on the screen. Is that accurate?
Yes. So you can either look at the drone, or you can look at the 3D cube on the computer. So the 3D cube is actually part of the Emotive software package that it comes with. This from the control panel, and that's where you do the actual training. So for the brain-drawn rays, and actually for this kind of demos, we actually tell people, just look at this cube, and you come from the cube will reflect to the drone. So you can still look at the drone and still think the same thing, and it will work, because it's not really based on the visual. I mean, on your eyes, is based on your cognitive commands, right? So, but again, because people are not really used to these kind of things, and then pretty much what we call novices, they had to look at the cube. Like I have been doing it for many years, because this is my research. So I pretty much sit down the first time. I did it for hundreds of times. So I can just look at the drone and I'm able to actually make it happen. But for the brain-drawn rays and for this kind of thing, they look at the cube, but they can still look at the drone, and it will actually work fine.
Excellent. So I need to ask you, since you've been doing this for years, at the brain-drawn race, were you able to sort of dominate those races, or?
So I did want to compete with the champion, but we were so tired by the end of the race. So like, you know what? One day I'll email you and then we race.
Okay.
But actually, we did a documentary for a French documentary, which will be released in March 2017, last week actually.
Okay.
And they had me competing there for like an hour. They're like, let's just shoot as many. Then I was just competing, and I was able to win.
All right.
Yeah.
And I'm thinking you're probably like, well, I should be able to. I put so much time into
Oh
this.
yes, I put so much time and training and creating my profile, and then like if I lose today, I'm just gonna drop out. Like, I should be able to win all these races. But no, that's one of the things with BCI. One of the challenges, like the more you train, the better you become.
Right.
So okay, people can do it like within minutes, like very short amount of minutes. But to become a mastering it and be able to actually the BCI to recognize your brainwaves even better, you have to really keep training it and keep training it. Okay. And there are even old research papers where they have researchers, they report data from researchers doing it for months, like 2 or 3 months. Mm-hmm. And that's one of the challenges of the BCI area. How can we maintain training very short and people be able to perform well, even if they wouldn't perform as well as somebody who trains for a year? But at least if they buy the BCI device, they're able to train regularly. So because they want to compete in a brain-drawn race,
right?
They become actually way better. But that's one of the challenges in our research. Like, how can we maintain a training shorter?
Okay.
Sometimes accurate at the same time. Yeah.
Let's see, where do I want to go with this? Where do you see, so the brain-drawn races may be, 2 to 3, where you see regionals or California? What do you think that's 2 to 3 years down the road for that type of mass adoption, or do you see that happening sooner?
I would say 2 to 3 years. I would say 3 to 4 mainly. 4. So the good thing is that there are a lot of companies and group of like drone groups that actually love the idea. So they reached out to us, the Drone Racing League reached out to us and say, hey, we really would like to partner with you guys. DJI, which was a drone that we used. Now, again, we come to the challenge. It's not just the drone, it's also the brain-computer interface. So when it comes to the environment where we actually host this race is extremely important. So, and that's one of the things we have to actually understand, okay, where can we host these races? Okay. But I pretty much see we can, we say the other schools doing this kind of races, hopefully the Drone Racing League will do something similar as well. We can partner with them. And but one thing I envision, they have Olympics for people in wheelchairs, right? So pretty much they can race. They can compete in this brain-drawn race with people who are not in a wheelchair. We no disadvantage whatsoever. All you need to do is just sit in a place and just really compete with somebody else. And that's what I want to see. I want to like equality in a specific sport where anybody can win. You can be a man, woman, or somebody who's not that, let's say, educated or even more educated, or people who are in a wheelchair. You can be missing an arm because, let's say, something happened or you were in the military. You can still compete at the same level who has have both hands. And that's what I see within the next 2 to 3 years, be able to start adapting that kind of mentality and say, okay, this is the sport for everybody. That's cool. And that's pretty much where we actually see it going. And hopefully we can have regionals for that.
Yeah, I like that. I mean, that's doing such social good with this brain computer interaction. It's just amazing. I didn't even think of it that way. What other uses, because we're coming up on about 30 minutes, so we got about 10 minutes left. What other uses do you see? And it doesn't have to be immediate uses. How about in the next 5 or 10 years, what type of uses do you see happening with the, obviously the artificial intelligence and robotics is growing rapidly, even exponentially. What do you see with for yourself, even beyond the drone racing in the BCI field?
Yes, so there's a new area called artistic brain computer interfaces. So it's pretty much visualizing the affective state in some sort of like audio in terms of from music or even art. When we pretty much can we actually brain paint? What is something called brain painting? We do painting through with the brain, and that's actually possible nowadays. But can we? What I'm thinking is, can we combine that with smart homes?
Ooh.
And let's say in the next 10 years, if you're wearing a BCI device at home, let's say you're mapped out with the Internet of Things nowadays, which is also another hot area. At least that's what Silicon Valley loves, Internet of Things. And the more you make these objects more smarter, can we, let's say, adapt the how bright are the lights based on how you feel? And can we actually make the colors of the lights based on how you feel to pretty much improve your emotional state? And that's one of the purposes of affective BCI. Let's improve your emotional state without you doing a lot of work. Or pretty much saying, okay, let me watch the video because I feel down. Let's actually have technology and objects adapting to you because we already know through machine learning, combining with BCI, that's pretty much Internet of Things, that's pretty much how can we see the smart home being used even at the workplace. There was an article recently on assessing how people actually, the employees actually feel at the workplace, because many of them feel they don't feel appreciated, but they don't speak, so they're very quiet. They're like, oh, I don't feel happy at my work. Can we assess that, right, with the BCI? Now, of course, there's a lot of question when it comes to security. We really had to pay attention to security. When is it too much? When is it like, okay, I'm assessing your brainwaves and your emotional state, but do I have that kind of permission from you?
Right.
Let's say from the workplace, also from your friends. Something I would like to see. I actually was the French documentary because they asked me, where do you see communication going? Not just from BCI side. I said, well, I would like to see communication with BCI in the sense that if I'm going to call Nick, right? I want to call Nick right now, but Nick is having such a hard time, right? But I don't know. Because, I don't really know. So can I open your contact in my phone and see how do you actually feel at that time? And say, oh, okay, Nick it feels kind of sad. I probably should give him a call because we're really good friends, right? So, but however, again, we go back to when it comes to security. When it like Nick, you should probably give me permission to see your emotional state, and probably at a specific times you don't want to see you want me to see your emotional state. But that's pretty much what I see in the next 10 years. Also, the brain drain race again expanding, and many companies adapting it, and be able to actually people be able to have their own brain drain equipment and be able to go to brain drain races and be able to actually compete. But smart homes, brain drain races, that's pretty much where I see it going from outside the medical field. In the medical field, again, is similar to smart homes, allowing neuroprosthesis to actually advance that area.
Okay.
Even exoskeleton. I don't know if you saw in the workup where they were just if somebody using exoskeleton. So that's pretty much where it's also going.
Okay.
Yeah.
And what about the military applications? Is that something you're trying to avoid, or because it sounds like you want to do a lot of good, but I could really see military to use this for their drone pilots.
True. So when military, when it comes to training, when I mentioned quantified self and BCI, they have a simulation training in the military, and that's a place where we can actually quantify the brain when we actually they are doing these kind of simulations, training simulations. When what they would like to use the BCI after that, then that's how be up to them.
Right.
But when as pretty much helping them through their training, and then if they're not performing well because of the mental state, because sometimes you don't perform well at the same specific sport because you're not feeling well, you're going through life right now. So it will be similar thing, right? What happening if you're training in the battlefield and then you're thinking about something else, it wouldn't probably go well. But if we were to assess that before you go to the battlefield, probably they can do some kind of protocol so they he will actually would be better prepared. Another domain where we actually see it well applied is in air traffic controllers.
Oh.
Yeah, these air traffic controllers, they have to pay attention of so many planes, and and some of them, they even start falling asleep, and that's a problem.
Right.
But if we can assess that, when that person starts getting drowsy, and probably give them some kind of notification saying you need to grab a cup of coffee right now, or probably we need to replace this person for 10 minutes so he can recalibrate, and then come back and do his job. Because they actually are responsible of thousands of lives every single day.
Right.
So can we assess how they actually are feeling on their affective state, that we can actually avoid any accidents?
Right.
Yeah, so that's pretty much where we see from the military side, even education in the military side. They are constantly learning how to use different technologies, or even different things. Can we assess, okay, how much that person has learned in some, and pretty much even for themselves as well, so they can improve.
And then would that maybe, I was going to say, would that educational would that help them to then guide determine the efficacy of that particular training module, or that? Yeah. Okay.
Yeah.
That would give you some indication there. All right. Before we wrap up, I'd like to know what items I should be watching for out of your department and from you in the next 6 months, the next year. It sounds like there's a documentary coming out in March of 2017. Yes. What else should I be keeping an eye on?
Well, definitely, my lab is planning the second Brainwave race here at the university. The specific details, we don't have one yet, as we're still planning. So that's one that will be in spring, sometime April 2017, okay. Just like this year will be in April as well. And that's one. And also the quantified self application that I mentioned for with brain-computer interfaces. We should have some kind of prototype in the next 6 months, where people pretty much will definitely be getting some data and understanding how useful this kind of application is with everyday user. We met everyday user for this kind of application. I will first start assessing college students. Actually would make sense. It's pretty much my environment, and but pretty much again, this kind of application will be able to be used for anybody, military or anywhere, if you would like to assess how much attention somebody is putting into. So that, and also my colleagues, Chris Crawford, that pretty much we work together in Brainwave Race, is working a framework for those who are not able to write, very good developers, to be able to create their own BCI applications without the need of a computer science background. And my other colleague, Frank Jackson, she has a user experience background, and she's thinking of creating a more aesthetically looking BCI, still making it accurate. So imagine will you take this to the club? So that's the thing. And
right.
When you go anywhere, like to a restaurant, and wear this, and how will people actually look? And she's trying to address those issues from a human factors perspective, and still keeping in mind the brain-computer interface, neuroscience background. How can we actually still keep those, but still make these devices more aesthetically? And all the three projects that I just mentioned, they actually are in collaboration with Intel. So okay. Intel was actually funding the Brainwave Race, and they were our sponsor, and also the three projects that you mentioned, the Quantified Self Framework, and what we call the sexy BCI. So I would say in the next 6 months to a year, if Intel doesn't drop something, we are going to be dropping something, or together we're going to doing something. Cool. But that's pretty much what's going to happen. But that's what's next.
Please. Anytime something's coming out, tweet me or DM me, and I'll share it as well. And
definitely.
Anything I can do to promote. And you may want to think about live streaming that brain drone race, because some people are going to find that really fascinating to watch.
Yeah, we actually did. We actually streamed it through Twitch.
Okay, good.
Yeah, so we probably might change it more a little bit, the live streaming. But I'll definitely keep that in mind.
Yeah, that's just to grow the audience of people interested in it. There's nothing wrong with that.
I know that's pretty much one of the main reasons of the Brandon race, to grow the audience. Everybody will know about it.
Excellent. Yeah, please. Anytime I can reshare something that you're working on, just DM me or just regular tweet me, and I'm happy to share it, because I love learning about these new technologies in the robotics, AI, and machine learning areas. Trying to teach myself here through promoting others, basically.
Yeah,
so this is great.
That's a good way to do it.
Yeah. Well, I really appreciate you coming, Marvin. And where can people reach you if they have questions or interested, they want to support? How do they reach you?
Yeah, so I'm going to write my email in the chat. So this is my email and my website as well, which I should be updating pretty soon again. So if they would like to send me an email with any question, they can send it to that email, and can sometimes have Google Hangouts with people and pretty much talk to them about how to proceed with BCI. Or they can also go to our Facebook page of the Brandon Race and check pretty much a lot of the things at Brandon Race, who were the winners. We have some videos also there, and how things actually happened. But yes, that's my email, and I'm sorry, that's actually my personal email.
I can delete the Gmail one.
Yeah, that's fine. It's actually
I'll delete that one.
And then this is actually my website.
There's your website.
But yes, that's my universal email, my website, and people can actually contact me through either or. Excellent.
Well, I want to thank you again, Marvin, for saying yes to this. I know I reached out to you just sort of out of the blue. But I found that that's the way to go. I read about somebody and I think what they're doing is interesting, so I reach out. Definitely. So I really appreciate it, and I thank you for your time tonight.
Thank you.
Thanks. Have a good one.
You too.
All right. Bye-bye.